Alright, so get ready for your mind to be blown. Alright, we are going to be learning about complex numbers and imaginary numbers. Yes, I said imaginary. They do exist, but they are different than the real numbers that we have normally been studying. So make sure you're following along and you have your notes ready. Alright, so here's our real number system that we're all used to, right? We have our natural numbers, we have our whole numbers, we have our integers, we have our rationals, and then all of these are rationals, right? And then we have our irrational numbers. Now notice how these are called the real number system, and we always want to specify, right? Whenever I ask you what's the solution, and the solution is all real numbers, it's very important that you say real because we have what's called imaginary numbers. Now they do exist, but they are separate from real numbers. Okay, so now we're going to talk about what imaginary numbers are. Alright, so imaginary numbers are all built on this unit called I. Okay, so I for imaginary. Every imaginary number is built off of this idea of I. Now I is equal to the square root of -1. So anytime you see I, you should think square root of -1. And anytime you see a negative underneath the radical, you should think, oh, well, that's an imaginary number I. Okay, so this is going to be the basis of everything we talk about imaginary numbers. So anytime you see I, you need to remember square root of -1. And anytime you see a negative, it's I. Okay, now if I want to multiply I times itself, so I times I, that's the same as saying the square root of -1 times the square root of -1, which is square root of -1 squared, right? And remember, this square root and this square kind of undo one another, okay? They undo one another and they cancel each other out, so I'm left with -1. So anytime you see I squared, it's -1. Now I want you to realize what just happened. We took a number that was so-called imaginary, right? We took I, which is an imaginary number, but when we multiply I times itself, we get a real number, -1. Okay, that's a big deal. All right, maybe not to you, but it is in mathematics. So when we take an imaginary number and we multiply it times itself, so I times I, we get a real number, -1, and this is going to be very useful, which means every time you see I squared, it needs to be simplified to -1. Alright, so simplifying some imaginary numbers. This gets a little tricky. So anytime you see I to a power, you have to remember I is the square root of -1, but I squared is -1. So as I go up in power, you need to use these properties, okay? So I is the square root of -1, and I squared is a -1. Therefore, I to the third power is the same as saying -I, okay? And then if I want to do I to the fourth power, where that's I times I times I times I, which remember, these guys give me I squared, these guys give me I squared, but remember I squared is -1, so that's -1 times -1, which gives me a +1. That's where this +1 came from. And then when I go I to the fifth, that's the same as doing I to the fourth times just one I, right? That's a 1 exponent right there. Therefore, I to the fourth we just said was 1. I to the first is the square root of -1, so we just end up getting I for I to the fifth. So you can see how that simplifies, okay? A little tricky at first. Don't worry. When you practice, you'll get it. But it's always good to remember to try to use your exponent properties to rewrite the number into something that you're familiar with, okay? So I rewrote I to the fifth as I to the fourth times I to the first because I knew what I to the fourth was. Or I rewrote I to the fourth over here is I squared times I squared because I knew what I squared was. So always have a reference point and use your exponent properties. Alright, so now we're going to be simplifying square roots whenever we have a negative inside. So I'm just going to be using my radical properties here, which say that anytime I have two numbers multiplied underneath the radical, I can split them up into two separate radicals. So for example here, the square root of -5, that's the same as saying -1 times 5, and then I can break that up into the square root of -1 times the square root of 5, and the square root of -1 is I, and then I just have my square root of 5. So that simplifies it. So you can see that really, I could skip this if I wanted to. All that happens, anytime you see a negative, that means the I pops out of the radical. So just doing another example kind of the long way. Looking at this is the same as -1 times 18. So that's going to be -1 times the square root of 18. So I see the I pop out, but remember we need to simplify 18. So remember 18 breaks down into 9 times 2. So the 9 will pop out and become a 3. And then the 2 stays inside. So that's simplified form for the square root of negative 18. Let's look at the square root of negative 32. So remember that I is going to pop out from this negative, so I can go ahead and rewrite this. That's I, the square root of 32. You can see how if you want to do the longer way you can, but then you can start using the shortcut. So immediately seeing the negative means an I is on the outside. Now I have a positive 32 underneath, and I just simplify like I normally do. So remember 32 breaks down into 2 times 16. 16 is a perfect square, so that 4 is going to pop out. Let me just rewrite that. That's 16 times 2. This guy right here is going to become a 4 when he pops out. So I'm going to be left with 4i radical 2. And that's going to be the simplified version of the square root of negative 32. And then over here, that's the same. Remember that negative means that the I pops out. So that's I times the square root of 25. Well, the square root of 25 is just 5. So that becomes 5i. And that's my final answer. Alright, so a very common mistake is that anytime you see squaring a negative number that's underneath the radical, that you want to automatically go, oh, well, anytime I square something it becomes positive, so this must be positive 5. Okay, but I don't want you to fall into that trap because that's incorrect. Alright, so there's a few ways to do this problem. I'll show you a couple. One way is to go, okay, well, squaring something means writing itself twice. So I'm going to go ahead and write it twice. Okay, and then you know that a negative means an I comes out. Okay, and then you combine like terms here. I times I is I squared. The square root of 5 times the square root of 5. Remember, whenever we multiply square roots, that's the same as going, okay, well, we write it underneath the same radical. So this must be the square root of 25, which is 5. So the square root of 5 times the square root of 5 is just 5. Now remember, I squared turns into negative 1, so this is negative 1 times 5. So the answer we get is negative 5. That's the correct answer, not positive 5. Now another way to do this is to know that this negative right here pops out and becomes an I. So this will be I times the square root of 5 squared. Okay, notice that the parentheses are still around both terms there. And then remember our exponent rules, it goes to both. So that's I squared. Now remember, square root of 5 squared is just 5. Okay, we touched on that before. And then I squared again is negative 1. So that's negative 1 times 5. So again, I get negative 5. So you could do it multiple ways. I just want you to see that just because I'm taking the square of a negative number, it does not become positive because it's underneath the radical. Alright, so we talked about what an imaginary number is, but whenever I combined imaginary numbers and real numbers, we get what's called the complex number system. Okay, so we have our real numbers, then we have our imaginary numbers, okay, and then we have our complex numbers. Alright, so complex numbers is combining real and imaginary together. So this is what it looks like, A plus BI, where this part right here is the imaginary part, and then this number in front is the real part. And when we add them together or subtract them, depending on the sign over here, we get a complex number. Now a pure imaginary number means that there is no real component, it's just 0 plus the imaginary number. Okay, so that's the difference there. 0 plus BI, or we can just write BI, is a pure imaginary number. And then a complex number is when there's a number added or subtracted along with the imaginary part. Now, when we're dealing with imaginary numbers, I want you to kind of use them just like you would a little bit as a variable would act, okay? So use I kind of like x would be. The only thing you need to constantly remember is that I squared is negative 1, because that's going to pop up a lot. So whenever I'm adding or subtracting, we add and subtract just like we normally would, except for we're going to do like terms. So real part to real part, imaginary part to imaginary part. So here, if I'm adding these guys together, now these parentheses aren't really doing much because this is addition in the middle. So really I'm going to do real part to real part. So 4 minus 4 is 0. And then I'm going to do imaginary part to imaginary part, which negative 3i plus 3i is 0. So I'm just going to get 0 for that. Okay. Now over here, I actually don't want to get tripped up here because if you notice, there's a minus in front of a parenthesis, which means I need to distribute. So I need to distribute this negative to both terms. So I'm left with 5 minus 3i. Distribute the negative. Negative times negative 2 gives me positive 2. Negative times 4i gives me negative 4i. And now I'm going to combine like terms. So remember, your like terms is real part, so that's 7. Imaginary, imaginary, so that's going to be negative 7i. So that's going to be my final answer, and this is a complex number. The real part is 7, and the imaginary part is negative 7i. So multiplying works exactly the same way, except for we want to constantly remember that I squared equals negative 1. That's going to happen a lot whenever we're multiplying. So you just double distribute. 4 times negative 1 is negative 4. 4 times negative 2i gives me negative 8i. And now I'm going to do the next one. 3i times negative 1 is negative 3i. And then I have 3i times negative 2i, which is a negative 6i squared. So I times I, remember, is I squared, just like x times x is x squared, right? You add the powers there. But now to simplify, I don't have any other real parts, so that's negative 4. And then I have negative 8i, negative 3i, so that's negative 11i. And then this guy here, the I squared will become a positive 1. I'm sorry, a negative 1. So then I'm going to have negative 6 times negative 1, which is a positive 6, plus 6i. One last step, I need to combine like terms here. So that's going to be negative 4 plus 6, which is a positive 2. So 2 minus 11i. And there is my complex number. The real part is 2. The imaginary part is negative 11i. All right, one more example. Just double distributing, right? Negative 6 times negative 6 gives me positive 36. Negative 6 times negative I gives me positive 6i. And then I'm going to do I times negative 6i, which is negative 6i. I times negative I gives me negative I squared. So combining like terms here, this and this is going to go away and give me 0. So I'm left with 36 plus, well, remember, I squared is negative 1. So this goes away and leaves me with the negative 1. And then I have minus, I have a negative 1 here, so minus a negative 1, which is plus 1. So I'm left with 37. Whoa, look at that. I went from having imaginary numbers to having real number. So we're going to talk about what types of numbers these guys are. So looking at the last example, you notice when we multiplied those two numbers together, we started out with complex numbers and we ended up with a real number. So the reason that happened is those two values were complex conjugates. Now all that means is that the imaginary parts of that number have different signs. And whenever they multiply together, we get a real number. So whenever I ask you to find the conjugate, I just need you to take that exact same number but change the sign of the imaginary part. Now I want to show you why that works. So here's the very generic complex number. We have a plus bi and a minus bi, which are both complex conjugates. So distributing, a times a is a squared. A times negative bi is negative abi. And then doing the next set, bi times a is positive a bi. Doesn't matter if you write a or b first. Bi times negative bi gives me negative b squared I squared. Now, combining like terms, you'll see that these two guys are the same, so they go away. And then I squared is negative 1. Now this negative 1 here times this negative will turn into a positive. So I'm going to be left with a squared plus bi. Now a and b are real numbers, so this number right here is a real number. So we started out with complex numbers and we ended up with a real number. So whenever you multiply something times its conjugate, you get a real number. So I want to find the conjugate of these numbers. Okay? So conjugate, remember, just means I take my complex number, which is a plus bi, or a minus bi, depending on how it's given to you, where a is the real part and b is the imaginary part. So here, the real part is 0, right? There's nothing written there. So if I just want to change the sign of the complex part, I just change this negative into a positive. So the complex conjugate is just 4i, positive 4i now. Now over here, if I have 8 plus 7i, the real part is 8, that stays the same. The imaginary part is going to change its sign. So its complex conjugate is 8 minus 7i. Okay, so notice all I did was change the sign of the imaginary part. Now up here, the imaginary part is positive 6i, so I just changed the sign, so that's negative 6i. Down here, the imaginary part is negative 4, so I'm going to keep the real part exactly how it is, change the sign of the imaginary part, so plus 4i. Now, where complex conjugates come into play is whenever I want to simplify a quotient. So anytime I see two imaginary numbers written in a fraction, we don't like that, okay? We don't want any imaginary numbers on the denominator of a fraction. So I need to rewrite this, okay? We cannot have an imaginary number in the denominator of a fraction. So the way I get rid of it is I multiply top and bottom by the conjugate of the denominator. So here, 3i, the conjugate's negative 3i. Now, of course, whatever you do to the bottom, you have to do the top. So I'm going to multiply top and bottom by negative 3i. So distributing that, 9 times negative 3i is negative 27i. And then 12i times negative 3i gives me negative 36i squared, right? Don't forget I times I is I squared. On the bottom here, I have to do 3i times negative 3i. Well, that's going to give me negative 9i squared. Now, simplifying the top, remember anytime you see an I squared, that's negative 1. So I'm going to get positive 36 minus 27i all over. Now remember this guy goes away, I get negative 1, so that's minus and a minus, so positive 9 on the bottom. Now, we always like to write it as real number plus or minus imaginary number. So breaking this up, 36 over 9 minus 27i over 9. And simplifying that, 36 divided by 9 gives me 4, minus 27 divided by 9, which is 3. So the correct simplified version of this is 4 minus 3i. So notice that the denominator is now gone. Now you may be wondering, up here at this step, why did I write the 36 first? Well, remember, for our complex numbers, we always like to write the real part plus or minus the imaginary part. So the real part needs to go first. Alright, so remember, the way we want to simplify this is by multiplying top and bottom by the conjugate of the denominator. So here, since it's 8 plus 7i, the conjugate is 8 minus 7i. So I'm going to multiply top and bottom by 8 minus 7i. Now I have a lot of distributing to do here. Okay, so on the top, let's do the top first. 8 times 8 gives me 64. 8 times negative 7i is going to give me negative 56i. And then I have negative 7i times 8, which is negative 56i again. Negative 7i times negative 7i, which is a positive 49i squared. Don't forget that. All over. Now on the bottom, don't just think that the imaginary numbers cancel each other out, okay? Make sure you distribute through. So 8 times 8 gives me 64. 8 times negative 7i is negative 56i. And then I have 7i times 8, which is going to give me positive 56i. And then 7i times negative 7i, so that's going to give me negative 49i squared. So now just simplifying everything. On the top, these guys and these guys will come together to give me a negative 112. And then this guy is going to turn into a negative 1, so that's a negative 49. On the bottom, these completely cancel each other out. That's the whole point of the conjugate, okay? If that doesn't happen, something went wrong, okay? This guy will turn into negative 1, so that'll be positive 49. So on the bottom, I get 64 plus 49. The top will simplify to 64 minus 49, so I'm just combining like terms here. This guy and this guy, combining them, so I get 15. So 15 minus 112i divided by 64 plus 49, which is 113. And then don't forget, we like to write this as real number plus or minus imaginary number. So I'm going to rewrite this as 15 over 113 minus 112i over 113. Now remember, if I could reduce, I would, but none of those fractions reduce. Alright, so we got a lot of examples to try. I'm going to check these in class. These will not go in your Google form, but please do your best, and then we're going to go over them in class.